multiplying radical expressions. If you recall, in the past we have done something like the square root of 2 times the square root of 2, and we talked about how that's the square root of 2 squared. And so you take the square root of anything squared and that undoes the square root. Well, another way to look at this is the square root of 2 times the square root of 2, and that's really the square root of 4. And so the square root of 4, we get that because we can combine radicals when multiplying. So if you look at the product property of radicals, it says that you can take any radicals and you can separate them, or you can put them back together again. So we can combine these two under one square root and get the square root of 4, which is 2. Now this helps us to simplify when we're doing multiplication of square roots, because for instance, the square root of 8 times the square root of 2, we don't know the square root of 8 or we don't know the square root of 2, but we do know the square root of 8 times 2, and because that's 16, and the square root of 16 is 4. So we took something that we didn't know the square roots of and we combined it to find the square roots of something we did know, which was a perfect square. So we're always looking here to find some way to simplify. So again, this is really the square root of 8 times 2, and that's the square root of 16, and that's 4. We can combine when we have things like 6 square root of 2 times 4 square root of 3. And we treat these like variables, so we're going to pull the 6 and 4 out front and rearrange. This is really 6 times 4 times the square root of 2 times the square root of 3. And so then we can combine those square roots. This is 24 times the square root of 2 times 3, which is 6. And we can't simplify that anymore, so we're all done. If you have 6 square root of 3 squared, that really means 6 square root of 3 times 6 square root of 3. Or 6 squared times the square root of 3 squared. So you can remember you can distribute that squared, and so really what we have then is 36 times the square root of 9, or we have the square root of 3 squared, which is just 3. And so we can multiply 36 times 3 and get 108. D here, we have variables now inside of our square roots. But we do the same things we've always done. The 2 is outside, so we're going to take and combine only the 6x and the 4x underneath the radicand. So this is 2 square root of 24 x squared. But now we need to break that down because that is not in simplified form. And so really we could have left it in prime factorization or factored out, because if you take a look at the square root of 6 times 4 times x, we can take some things out of the square root, because we know the square root of 4 is 2. We know that the square root of x squared, or x times x, is x. We also have this other 2 out front that we need to bring down, and the only thing left inside the square root is the 6. So we have 4x times the square root of 6. So sometimes we need to put them together and then pull them back apart in order to simplify what we have. We can multiply using the distributive property with square roots as well. So here we're going to take square root of 2 times 3, and I'm going to rewrite that as 3 square root 2 because we always want the number that doesn't have a radical in front of the one that does. And then I'm going to multiply square root of 2 times the square root of 6. The first one we can't simplify any, but the second one we can, because that's really the square root of 2 times 2 times 3. Using prime factorization, we can then pull the square root of 2 times 2 out of there. So then this one is really 2 square root 3 plus 3 square root 2. And if you remember back to our lesson on adding like terms, for radicals, can we add these together? We cannot, because the square root of 2 and the square root of 3 are not exactly the same, so this is your final answer. So here's another problem, both square roots on both parts. So again, we're going to take the square root of 2 times the square root of 6, and the square root of 2 times the square root of 9. And then we're going to see if we can simplify anything. Well, we just got done doing the square root of 2 times square root of 6 on that first problem, so we know that that is the square root of 2 times 3. That's 2 times the square root of 3. Minus, here we can take the square root of 9 out right away. That's 3, and we're left with the square root of 2. And again, we can't add those together because the square root of 2 and the square root of 3 are not alike, so there is your final answer for that. Multiplying binomials with radicals. This is using the FOIL or box method to do distributive property twice, basically. So we're going to go 4 times 2, 4 times negative 6, square root of 6. And again, I'm going to put the radical in front. And then 9 times, square root of 9 times 2. And again, I'm going to put the the whole number in front and the radical behind. And then last, square root of 9 times the square root of 6. Okay, then we need to simplify all these parts and see if we can add anything together. 4 times 2 is 8. 4 square root of 6, I can't simplify because square root of 6 is 2 times 3, and neither one of those have a pair, so we can't take them out. Square root of 9 is 3. So really that's 2 times 3, which is 6. And then again, square root of 9 is 3, and we can't do anything with the square root of 6. So minus 3 square root 6. And then we check and see if we can do any adding like terms. Sure we can, because negative 4 square root 6 and negative 3 square root 6 is negative 7 square root 6. And 6 plus 8 is 14. So we finally got this down, and it's down to 2 terms when we're done. So the next one, 6 minus the square root of 3 squared. That really means 6 minus square root of 3 times 6 minus square root of 3. And we're going to do the same thing we did in the problem before by using FOIL or distributive property. So 6 times 6 is 36. This is minus 6 square root of 3. Minus 6 square root of 3, and then minus, actually plus, negative times negative is positive, 3 square root of 3 times square root of 3. And so really what we have is 36. These two can be combined, and so we have a negative 12 square root of 3, and the square root of 3 squared is 3, so plus 3. And we can do one more combining step here, and that is 36 plus 3 is 39 minus 12 square root 3. Applications. If we have carpeting, it says a rug has a side length of 8 plus square root of 5 and a width of 2 plus square root of 2, and they want to find the area. Well, area is the length times the width. And so the length is 8 plus square root of 5 times 2 plus the square root of 2, which is the width. And so our area is going to be this simplified form of these two binomials multiplied together. And so do the distributive property. 8 times 2 plus 8 square root 2 plus 2 square root 5 plus square root of 2 times square root of 5. And again, I just did the distributive property there, and I put the numbers in front of the radicals so that they're always behind, except when we have 2 of them at the end there. So then do the simplifying and see if there's anything you can add together here. This is 8 times 2 is 16, 8 square root of 2 is simplified because square root of 2 can't be broken down anymore. 2 square root of 5 is simplified because it can't be broken down anymore. 5 can't. And then 2 and 5 can't be broken down, so that's just plus the square root of 10. So we're combining those back together as a square root of 2 times 5. And neither one of those can be broken down. We don't know the square root of 2 or 5 or 10. So this is your final answer because we cannot add these together because they do not have like radicals. This concludes multiplying with radicals.